morning, everyone. Thank you for being here. My name is Scott Murdy. I lead the healthcare consulting practice here at KraftCPAs, and we have a very exciting panel discussion today on blockchain and how it affects healthcare. I'm going to briefly introduce the panelists, and then we'll let them talk a little bit more about themselves and their background and how their experience with blockchain relates. But starting out on your right is Kristin Dawn. She is an attorney at Waller, where she leads their blockchain practice. In the middle is Emily Vaughn, and she's the product development director for Change Healthcare. And then finally, Giles Ward is the chief operating officer at Hashed Healthcare. And today, this topic is something that we could be talking all day about. But I know all of us have other things to do, so we're going to try and condense it. They're going to go through, talk about some specific issues at kind of a 10,000-foot level, but anywhere where we want to dive in and talk deeper, we can certainly do that or deviate off topic. Feel free to ask questions. This is being recorded, so we're going to try and repeat your questions so that the mics do pick up your questions if you have any. But starting out, we'll start with Kristin, and I'm going to have her talk a little bit about her background and how it relates to blockchain.
I'm Kristin Dawn. I'm a partner at Waller. Like Scott said, I do lead the blockchain practice. I'm in the IP group. I'm a patent attorney, but most of what I do is transactional. Since blockchain has taken off in a major way, we've assembled a pretty good team of all parts of Waller lanes, and they're helping with the blockchain efforts. And we've been working on this for 2 or 3 years now. And we're excited to be here. Talk some more.
Hi, I'm Emily Vaughn. I'm the product development director at Change Healthcare for blockchain. I come from the blockchain industry. I've worked in the Bitcoin or blockchain industry, working mostly for startups since 2014, and was kind of investing in Bitcoin and being a skeptic, in the years before that. So I'm very familiar with the Bitcoin blockchain world, and that's what I'm bringing into the healthcare technology world now. And my background's really in business development and marketing, and learning the technology and learning the product has been kind of the new frontier for me.
This guy, my name's Giles Ward, and we were laughing. We complete the WebMD. Thank you, Giles.
Got it.
The WebMD MD on Change alumni panel up here, because we've all. But I started in healthcare at WebMD, and then spent most of the last 10 years running dialysis centers. And as we sold that, the guys that started Hashed Health, John Bass and Corey Todaro, had sort of found Charlie Martin in town, and after we sold DSI, I sort of took some time off, and then when I came back in, they were like, "We got to do this. This is happening. This is real in healthcare." And Charlie got excited, and we launched Hashed Health on the stage of Distributed Health, which is it's still the world's largest healthcare-focused blockchain conference, and it's here in Nashville. So I'd put it on your calendars. It's, I think, November 5th and 6th this year, and it is, I remember the first year people raised their hands. We asked who has never been to Nashville before, and I'd say 2/3 of the room raised their hands, and you thought there were probably 30 countries represented, and people had come in for a one-day conference. The biggest complaint afterwards was, it's a long way to travel for a one-day conference. Can you make it 2? So this year is it's worth putting on your calendar. But anyway, Hashed Health is bringing the goal of the company was to create a conversation at the intersection of healthcare and blockchain, and then to build applications to solve the biggest problems in the biggest challenges facing healthcare where blockchain was appropriate.
Very good. Thank you, Giles. Emily, can you explain to us the difference between cryptocurrency and blockchain?
Sure. So diving right in, guys. Hope you guys have your coffee. So yeah, you've probably heard of cryptocurrencies before in the form of Bitcoin, maybe Ether, Litecoin. These are tokens that have gained a lot of consumer popularity as an investment vehicle. People are buying them as a speculative tool. They're holding them. They're selling them, hopefully, at a higher price than what they bought. Maybe sometimes not, depending on what's going on. But the cryptocurrency application is an application that runs on top of a blockchain network. And so a blockchain is two things. One, it's a rule set, it's a protocol. You talk about the blockchain protocol, and that is the rules that govern how transactions can get added to the network and then replicated across the network. And every blockchain protocol, whether it's Bitcoin or Ethereum or Litecoin, they operate just a little bit differently, which means that their tokens are just a little bit nuanced to that effect. So the token is an application that lives on top of this rule set that everyone in the network agrees to, and they're a little bit different than say a normal like digital cash, because the token is actually produced by this distributed network of computers rather than being produced by one central agency that's issuing it for everyone else. So when we talk about cryptocurrencies, we're talking about this digital form of value that can be transferred between people, between companies. It can be used to program applications, to automate certain things. And when we talk about blockchains, we're talking about this rule structure for how transactions get added to a ledger, and we're talking about the network of transactions that have been sort of replicated across this group of computers. And blockchain networks, these transactions, they don't just have to track currencies. I think that's the biggest takeaway for healthcare, is that as an accounting system, they can account for more than just a digital token. They can account for other types of digital assets. And that's where a lot of healthcare applications start to unfold, because you could represent an identity or a piece of data as a unique digital asset. And then you can use the blockchain to track interactions with that asset across multiple users and computers and disparate data systems.
Great, thank you. Did everyone get that? Y'all going to come back and explain that? You're all All right, Kristin, from a legal perspective, how does blockchain impact HIPAA and high tech within a healthcare organization?
That's a question I think all of us can answer, so I'll start and then we can go down the line, because we might have different perspectives. You're good. So as Emily just noted, this technology is not limited to one entity that's in control of what's happening within the technology. So you can use this pretty much wherever you are in the world, which is where regulations like HIPAA and high tech start to get a little complicated, because they're obviously jurisdictional, right? So now that we've acknowledged that, maybe we'll set that aside and focus, and pretend like we're in the U.S., and we're going to build an application where the intended users are in the U.S. The exciting and fun part of this, at least for me and what we're doing, is that you can come to me and say, hey, I have an idea, this is what I want to do, and you can build it. And a lot of people are getting in a lot of trouble right now for doing that, right? They get really excited. They don't talk to the attorney, but they build it, and then they say, this is so great, look what I've done, the technology is fantastic, and it turns out it's not legal. You're defrauding people, or you're violating some kind of huge regulation, right? But the cool thing that I've seen is that regulators want to learn, and regulators want to be a part of the technological solutions that are being built. So you can't really build a healthcare-specific application when you're going to be incorporating PHI and ignore HIPAA, period. And beyond that, it's going to depend on what the actual application is, how HIPAA and other healthcare regulations affect whatever it is that you've built. Anything else? Because you guys, I'm sure, have thoughts.
Yeah, I mean, I would just add that, in the way that, so a blockchain ledger is this ledger of transactions, and it's replicated across a whole network of computers, meaning every computer that has access has a full copy. So when we're talking about a HIPAA and privacy, there becomes maybe a requirement on application designers and software developers who are using blockchains to transact around patient data to make sure that they're not using the blockchain in an inappropriate way. And so HIPAA as a guidance already exists to tell technologists and business people how to use digital systems. You don't necessarily have to rewrite the HIPAA guidance for blockchain technology. You just have to use blockchain technology in compliance with what HIPAA requirements are. And I will say that what's interesting is so much of the conversation around HIPAA really focuses on privacy. And there's a second component to HIPAA, which is portability. And blockchains as a distributed network where an individual can easily get access to this, this ease of access lends itself to a better portability system and allowing patients to sort of be more engaged as part of the record-keeping life cycle. And this technically has been a very difficult thing for us to achieve in the past, but with blockchain technology, we might actually be able to have better portability around these health records without sacrificing their privacy and security.
And just piggyback on that, I think HIPAA, securities law, like the rules are in place, and just because it's new technology, I think a lot of people in this space are building things and then going back to say why it's different or why the law doesn't apply. But I think the logical approach to this is know the rules, let the governing bodies like the SEC know what you're doing, get opinions all the way through the process, but until those rules change, know that that's the law. So it doesn't matter, like the SEC's made it very clear, it doesn't matter what jurisdiction you set things up in. Like if you're in the Cayman Islands or in Gibraltar or in, like if you're, if you still fall under their rule sets if you're doing business in the U.S. So I think as we've gone through these things and as we look at how data is stored and how value is transferred, we feel like the rules are clear, and one of the guys in our firm, Les Wilkinson, he's like, my number one career goal is never to go to jail. And he throws that at us often. So it's a pretty good guideline. Everything else comes behind that one.
So Giles, where are we today in blockchain as far as its implementation, particularly within the healthcare industry? So
we are early days in this. I think we often use the internet as a sort of a technology that sort of projects where we're going with blockchain. Like some people say that we're still in the dial-up days of blockchain. I think we're probably in the days of like that first graphic browser, like the Mozilla Mosaic days, where people are just starting to say like wait a second, like this is cool. I can check the weather in Tokyo. There's just the light bulbs are starting to go on. But as people talk about portable patient medical records and some of these projects, they're really cool applications, but they're really far down the road. I think that we say that we're probably, we think about when the internet was invented. So like graphic browsers started in sort of 95, like the internet on sort of college campuses was starting to get pretty common in sort of like 92, 93. I remember going to find a basement computer lab and getting my first email address in 1993, and like there was clearly not a process for it. Like it was not a common request. But we quickly moved to where people saw the utility in it, but then think how long it was between that moment and like 2008 when the first iPhone came out. So like we are probably, 5-10 years away from the iPhone moment in blockchain space. And then when you think about that, like try explain Uber to someone in 1995. Like there were so many steps that had to come before that made any sense to someone in the room. And I think that's pretty close to where we are in blockchain world. But I think it's going to move a lot faster, and people are using the sort of path that internet took and the adoption curve as a sort of wake-up call. Like some of the people that were a little late to the internet are seeing this and saying, I'm not going to be late to this one. So it's probably, we say, probably every 3 or 4 months in blockchain time is a year in everybody else's time. So,
Emily or Kristin, do you have anything to add to that from a healthcare perspective?
I mean, I definitely agree with Giles' perspective that blockchain is in the early 90s if we're likening it to the internet. And I would just add a statistic to that. So between 1994 and 1996, there went from 3 million people on the internet to 30 million people on the internet. And then from 2013, which is when I got involved with Bitcoin, there was probably about 1 million to 2 million Bitcoin users worldwide, like people who had Bitcoin wallets. And the number of people, consumers who have blockchain wallets of some kind of crypto asset today, so this is, about 5 years later, is around 30 million. And so you're seeing a consumer jump in this technology that's very similar to the adoption of the internet. And so I think that it will be interesting to see if consumer adoption of cryptocurrency and blockchain digital assets actually impacts healthcare adoption of this technology, where you have patients who have wallets who have figured this out, who say, I want to manage my health records this way now. And that, pushing the healthcare industry to adopt this faster, similar to how digital health was kind of a consumer push. And so I think the difference now between when healthcare went digital, 15 years ago, and what's happening today is that we have the internet and we have mobility technology, and where the financial industry is having to adopt blockchain in the context of all of this technology that they've already built. I think that the healthcare industry may be able to leapfrog some of these systems and go to a patient wallet or an engagement platform that's really next generation because we can and the timing's right. So that's what I'm really excited about from a consumer perspective. But again, that's still a few years out. The consumer experience of blockchain technology isn't ready for most patients, I don't think. So.
All right. Emily, who are the stakeholders in blockchain?
Yeah, so I think that's a really important question because often you hear this word blockchain and you hear about these exciting use cases and people want to know, okay, so how is this going to impact me? What role do I play in this ecosystem? And I think it's really important to remember what blockchain technology really is. It's a networking technology like internet networking technology is. It exists in the back end of systems. It runs on servers. And so if you are a blockchain engineer or a company that's going to deploy blockchain networks, you're a network technologist. So I would say that the first group of stakeholders are the IT groups that provide network infrastructure. And this should make sense. You see groups like IBM, AWS, Microsoft, people who provide cloud infrastructure investing heavily into blockchain technology and trying to make it usable for the next group of stakeholders who are the software developers. And then you have your software end users, which could be in the healthcare industry, hospitals, health plans, groups that don't build their own software but buy it from other companies and maybe integrate it or implement it to their specific world. And then you have the end users of the end users, like the patients, the doctors, the actual individuals who interact with the software. And they may not be the actual decision makers in what gets purchased, but they are the sort of edge of the ecosystem, and their interaction with this network is really important in a blockchain ecosystem because the edge participants are just as important as sort of the nodes who process the transactions. So I think it's important to realize sort of where this technology fits, because if you're a hospital and you want to adopt blockchain technology today, it may not be really mature enough for you to adopt in the way that you buy your other software. And so the requirement for a hospital to do blockchain may be that they're deploying nodes and network infrastructure, and they're standing up, cloud instances. And this is not a typical process for just, a basic, innovation team who's just trying to understand this stuff. So I think understanding who the stakeholders are within the ecosystem will help you understand sort of what path your company should take in terms of investment.
Okay, great, thank you. Does anyone have any questions at this time before we move on? Yeah.
You didn't mention government as a, they always try to get in after the fact.
So government related to blockchain, we did talk briefly about the regulators, which essentially is the government. But anything to add to the government involvement with blockchain?
Yeah, hi. So the question involves the government and how they would be involved in the ecosystem Emily just described, and really the government is involved, I guess, in the payer side when they're providing reimbursement, but then they're also they serve two roles, right? Reimbursement and then also oversight. So the oversight is clear and exciting if you adopt certain blockchain technology in certain ways, because the record of the transactions or whatever's happened is there. So it's a very clear trail. Oversight, in the theory, depending on how it's applied, could be a lot easier. Again, the payment mechanism, to me, that's just one piece of how this technology will be deployed. And so it's not, based on the way you phrased your question, it's not the dark cloud or the gorilla that's being ignored in any way. I think it's very much a partner and an important role, but not a big bad presence that we didn't mention. It's just part of the, yeah. Go ahead, Joe.
Nobody's mentioned GDPR yet. Are they a player right up there now with HIPAA?
I can answer that, yeah. So GDPR stands for General Data Protection Regulation. This is a different conference altogether because GDPR is the European regulation related to privacy and acknowledging in a regulatory way the private right of citizens to control over their data. GDPR will play a role in everything that we do now, because even though it's a European regulation, it has direct effects on what happens here in the U.S. and to how we build and do things here. If we're going to, again, we're speaking about blockchain technology at a very high level, right, and its applications and potential. But when you're talking about GDPR, it gets down to how whatever technology, how you're deploying and using blockchain technology. So if you go back to what Emily said, and you have your data and it's portable and you have control over it, that's exactly what GDPR is trying to achieve. Yeah. So all of these regulations are always going to be an issue, but at the end of the day, you have to look at what it's actually built, how it's being used, and then the regulatory effects, if any, based on that.
Are there any conflicts between GDPR and HIPAA?
Joe asked if there are any conflicts between GDPR and HIPAA. There are. Again, at a high level, HIPAA regulates how PHI is shared among entities, right? And it's enforced among different entities, not people. GDPR is a little bit different in HIPAA in that way because it addresses a person's privacy. So I don't know that it's a conflict. I think it's a difference. Do they both apply in this setting? Yes. GDPR, when I'm talking to clients about GDPR in the healthcare setting, GDPR is not the big bad gorilla, because the beautiful thing about healthcare and GDPR is that people are already paying attention to the data they have, how they use it and access it, right? They already know what they have. A lot of other entities that are not in as highly regulated space don't really have that much knowledge or control over what's happening in their infrastructures. So yes, it's all relevant. How it's relevant is a very detailed question. Don't have anything else to add.
Yeah, I would just say in the conversations that I've had with American regulators and policymakers around the role of the government in blockchain for healthcare has been less that the government is going to take the position that if you're going to build some system with blockchain, you have to use this technology and you have to use these methods. It's more likely that they will say, they will take the role of protecting the constituent, protecting the patient, whether it's the data about the patient or whether it's the patient's investment, say, into an insurance plan that's being managed through the blockchain or something. So what they will say is, the patient's privacy should be protected. If the patient, says that their consent around how their data is shared, so this is a GDPR connection of how the patient's consent into that contract is being protected, protected, the government is more likely to basically say these are the things that must be protected, and this is sort of the position that we're going to take. And if you look at how the government has approached this in the financial space, you know, Bitcoin existed for a while, and like the SEC and the different, the IRS, the different bodies that deal with money, they were like not really sure how to handle Bitcoin. And it was only when companies like BitPay and Coinbase started offering payment processing services where they're like, that's a regulated activity. You need a money transmitter license. And then there was a question about, well, do we need to have a different license in every single state? And so the government, the regulators then step in and they say, okay, let's have a conversation about what's reasonable here. And so they're talking about the regulation of practicing a business using this technology, but they're still fitting it to the context of, it doesn't matter if this is dollars, Litecoin, Monero, Bitcoin, it's payment processing. So you need to have these payment processing, requirements. And so I would think that the same would apply in healthcare. Once you start using blockchains to send patient data, you're going to have to be able to prove that you're doing that in a HIPAA-compliant fashion. And what's brilliant about blockchain is that you actually can prove those things. It's this network. It's cryptographically secure, so you can use math to prove that things are behaving the way that you programmed them to behave.
I think what's important for us in the blockchain community now, and I think we're doing quite a lot of it, is getting out and talking to the regulators and the lawmakers. We've spent time up in Washington. Emily and I spent time up in front of some committees on the Tennessee Hill, not so much advocating for policy, but just saying like what this is. Why is blockchain different from Bitcoin? What is, like, I think it's important for regulators to understand how this technology is evolving and how it's different from the big scary sort of dark web things they hear about, so that the laws they make are thoughtful. And I think our approach up here in Tennessee was just like, there are businesses that are moving to Tennessee and thriving in Tennessee, so know that you have people in your districts and companies that are growing and sort of bringing attention to sort of Nashville, Memphis, around this technology. So don't make ill-advised laws based on what you think. Like there's knowledge in your districts. And then in D.C., I feel like on the Hill, there's a growing understanding. I think there's a growing blockchain caucus. I don't think there's any members of the Senate yet, but on the House side, it's a pretty strong one. And we've done education days on the Hill where you just go around and kind of educate the staffers on what's happening and why it's important. But then you go down to the agencies. You look at like the IRS and the SEC and the CDC and the FDA. Like, there's a sophisticated level of understanding of what blockchain is and how they're thinking about it. And then like IRS and SEC, I think probably some of the leading, like the level of understanding within those agencies about how this technology works is probably as good as anything in the private sector at the moment. Like and then you look at the way these agencies are looking at how blockchain is going to impact their futures. So
I would agree with that. I think that some of the first adopters would be government agencies of blockchain technology, because it's this brilliant accounting system that can persist independent of any sort of group who's in control at that period of time. You can have this network that persists. So I've seen a lot of similar use cases coming out of the agencies as well.
One of the quotes I've heard from a regulator is, I'd rather go on a treasure hunt than go to a surprise party. So they're very much willing to be along for the ride in this treasure hunt as we work through these different technical and legal issues.
From a security aspect, Giles, talk to us about there's with any kind of technology, there's a human element. So how does that impact security with blockchain?
Maybe we'll go back. I think if we started, I don't know that I've ever heard two people define blockchain the same way, but like a blockchain is it's a rule set, but it's an append-only data structure that's distributed. So rather than your data and my data, it's the data structure that sits between us. So if you think about participants in a value chain, like if you have a producer, a shipper, a warehouse, a distribution point, and an endpoint, and then a consumer, like all of those participants in a value chain keep track of their own, like we can use inventory in this case. If you move the record of that unit of value moving through a chain, and say, rather than all of us keeping our own records and then reconciling, let's agree on the rules and share a data structure. And now the sort of source of truth sits between us, and there's no question, there's no reconciliation. So, like, just think about how much easier that is to sort of, like, pay a bill, know an inventory, know a volume discount, know where you stand against a contract. It's you don't build your own blockchain. There's not a lot of value to setting something up internally. We talk to clients and they say, look, this department and this department never agree. They can never get their record straight. So we want to move their record keeping to a blockchain. Like that's an internal controls issue. Like that's governance, not like technology is not going to solve that. But maybe the process of implementing that technology would solve it because you'd force them to agree on how it's done. But you don't need a blockchain to do that. You just need a strong leader or someone that understands the problem. So, like on the security side, if you think about many copies of the same ledger, so as a transaction happens, it's broadcast to all the nodes on the network, and now everybody has a copy. So if you change something on your node, every other node on the network is going to look at you and say you're out of sync and either split you off or overwrite you and move on. So the scalable security of blockchain is, like, in order to make a change to a record, you would have to make that change on more than 51% of the nodes before the next sort of cycle closed. And on some networks, the Ethereum network, I think it's down under 15 seconds. So you think about tens of thousands of copies of that data. Like there's not enough computing power on the planet to make changes like that and have them stick. So the sort of cost benefit is the resources you'd have to throw at that would not bring a reasonable return. And if you have that kind of know-how, and like there are other places you could put that computing power that would probably have far greater like short-term returns.
Question. Yeah, I've got I wanted to ask for a comment about GDPR and blockchain. But first, just to say that it's a real wonderment how it seems like it's a new age when IT is so connected to and part of governance and regulations, lawmakers who don't even can't spell it, but perhaps. So like Tennessee has a new one-page law a couple of months ago, which is terrific. Basically just the definition, except it does have the legal question of you can't claim a property right once it's sold it by the fact that you have an immutable ownership recorded in a blockchain. And we talked with a IT guy in Florida who works with the state. He's not a member of the state, but he helped put together the Department of Administrative Services, which is putting all IT into one department, supposedly. And they're interested, but see what comes before blockchain is they're not even on the cloud. So when you look at all the states, and the ones that we know about, the cloud has to come first. They're fighting that, so that's starting to happen in little bits and pieces. But I'm wondering, when you have data GDPR says you have an absolute right to delete it, then there's like does the tree really fall down if no one is supposed to hear it? I don't know if there's a legal workaround or what would you say about that deletion?
The phrase I've heard is garbage in, garbage forever. It's tough, right? And I honestly don't know what's going to happen there, because if it's recorded and it shouldn't have been, and it's just like you said. So the answer for me is I don't know, but I just don't know.
Just watch the cases. Yes. So who's the first to sue and why?
Or enforce, right? So the regulatory bodies in Europe are going to have to care about what's been recorded. Again, like at a high level, we can talk about this, and at a high level, I don't know, but at the end of the day, it'll get down to a specific application and what that garbage is to know how it's going to be enforced and what the penalties are associated with that. I just don't know.
I'd say so blockchain it's not an efficient store of data. I used the example, I sat down with some guys at the Vanderbilt Radiology Department, and we worked out that they create more data every 12 days than the Bitcoin blockchain has created in its history. So you're not storing massive amounts of data on the blockchain. So when we get to patient records, like you're never storing, I don't see a path to us ever storing PHI on a blockchain, especially on a public blockchain. So you may have paths to where that data is stored, and you could delete those endpoints, which would disconnect the index from the data that's behind it. But I think that there are ways that blockchain and GDPR will coexist very well.
Yeah, I mean, I would add, I think it's important to kind of talk about what goes on the blockchain and what doesn't. So you have this concept of like a file store, like Google Drive. You just send it to the cloud and you store your photos and your documents there. You can also use Google's business suite to like collaborate, so you can share a doc with someone else, and then you can both be editing the doc kind of at the same time, and you can see them in there working alongside you. And this is made possible because that doc is stored in the cloud, and you are both, users into that software. So blockchain is very different from that, because a blockchain is a transactional ledger. So each transaction that gets added to the blockchain has to be kind of around the same size in order to ensure that the rest of the network that's processing those transactions can do so efficiently. So if I send a Bitcoin transaction to Giles, and it's about the size, like from a storage perspective, the size of a text message, and then Kristin sends me an image over the Bitcoin blockchain, that's going to be, multiple kilobytes, because it's a file image, it's a JPEG, and that will slow down the transactional speed of the blockchain. So from an efficiency and just from how the engine works, you just don't put large files in a blockchain transaction. Then from a security standpoint, of course, everything you put into a blockchain transaction is replicated over the whole network of computers that use that blockchain, so anyone else could see the full contents of that file. So what we do in healthcare when we use blockchains is the data, say it's a patient record or it's an image, we create a signature for that file, and it's a unique signature that identifies that record, and it's like a string of text, and we publish that to the blockchain along with like a URL or a location where you could find that record. And so what happens is down the road, when someone wants to retrieve that record, they can get the file by querying it through the blockchain or pulling it down from their application, and they can compare the data that they have. They can, retrieve a new signature from it. This is a process called hashing, but they run this program over it, and it produces a signature, and they can compare the signature from the historical record on the blockchain to the data they have in front of them to see if they match. And if they don't match, then they know that the data they have now has been modified or tampered with since the record was originally created. And so, again, what's going on the blockchain is just an identifier that represents this data that allows you to prove the integrity of the data at a later date. And that's kind of the sort of, there's a technical power in that when we think about what that could mean for automation, being able to make sure that your data hasn't been messed with, and we're going to automate applications on top of that. But I think that that's just an important thing to keep in mind when we talk about the transparency and the replication of blockchain data. We're not actually putting PHI or even really human readable data in those transactions. And that's both from a personal security standpoint, but also just from an efficiency standpoint. You can use blockchain transactional data to identify people who sent this transaction, who created this. So it's best practices these days to kind of mask all of that, so that when you're looking at the ledger, you don't know who the identity is of the person who sent it, you don't know where it's going, and you have no idea what the message really means. You can only decrypt it if you have the keys.
So from a patient perspective, right now, if I want to look at my medical record, I log into whatever provider I was at in their patient portal, and it may be connected to the hospital he or she practices at. I may be able to see some other tests. But how will blockchain, or how is it different than a portal that a patient logs into?
So, you know, right now, there's not a connection, a real meaningful connection between blockchain networks and patient portals, so there's not really like a difference. But I would say that, you know, from the way things operate today is for every physician that you see, you have a patient portal login. If you are savvy enough, maybe you see all of your physicians within the same hospital system and you have one login, and maybe that works for you, but that's not most people's healthcare experience. And so for every doctor you see, you have this unique portal. And your records are stored there. And I think that it's important to know on the back end that your data is stored in the cloud or within the EHR of that hospital system, which is why you have a unique portal access to that private ecosystem. What the blockchain is suggesting is the addition of a new data ecosystem that all of the EHRs could share. And it's an environment in which they could create a unique identity for you. And the difference would then be that you could have maybe one app that you authenticate all of your patient portal apps to, and then that becomes the world that you manage your patient records from, kind of like a Mint for healthcare, like a mint.com for healthcare, or you know how you log into things with Facebook. It would be kind of a replacement for that, and a more secure replacement if we can figure out the whole, you know, what happens when you forget your password problem. Because the great thing about Facebook is if you forget your password, they can issue you a new one. On the blockchain, if you lose your private keys, that's not easily, you know, returned to you. So that could lock you out of different things. So from a user experience perspective, there's a lot of work that we have to do before this tech is really useful for patients. But the idea would be that it could give you more autonomy within the system rather than just kind of being an endpoint.
So you're saying that blockchain doesn't eliminate like Allscripts or Cerner or Epic, that they exist within the blockchain as they are?
Yeah, I mean, so what's interesting and what's very different about blockchain technology, blockchain networks as a collaborative environment versus a cloud network as a collaborative environment. In the cloud, you have to send all of your data to the cloud in order to collaborate with the other members of that network. In a blockchain, you can keep your data private and within your system, and what you're publishing to the shared environment is a proof of existence. This is the data that I have, and these are the rights of the users within my network and the users who can operate with my data. And so it's much more of an at-will sort of like engagement that you can make, because you're pushing your transactions, you're publishing the assets that you want to collaborate with others around, rather than sending all of your data up there. And so in the Epic Cerner EHR example, these EHRs would still have their private data ecosystems. What they would have is an additional shared data ecosystem that would allow them to create a shared identifier system for patient IDs, or a shared identifier system for physician IDs. You know, just being able to know who the doctors are that are sharing these records across different systems. So having a universal identity system and a universal system for doing data access management, being able to have that in a shared environment where there is no central counterparty kind of controlling everything is actually really powerful, because it allows businesses to stay competitive while then sharing what should be commoditized.
So what exists today in healthcare from a technology standpoint that blockchain potentially eliminates?
So in 5 years,
Everything.
yeah, everything. Man, so I would say in 5 years, blockchains are going to dramatically reduce the need for all these complicated API situations. Like if you're trying to set up an interoperable system where your data can speak to all these other data ecosystems, the popular new gen way to do that is to set up point-to-point API communications with everyone you want to share data with. You could be sharing thousands of API connections. Those are expensive and complicated, and they don't actually, there's a latency issue there. So blockchain, you could program the functions of an API into the smart contracts of a blockchain, and then you make you maintain a couple of points of connection to that blockchain, and you use the blockchain to collaborate with all the other apps. And so I think the blockchain networks will dramatically reduce the need for APIs, and that's a short-term thing. I know we don't have a lot of API adoption in healthcare yet, but in 20 years, what blockchains will probably reduce the need for or eliminate the need for are like EDI servers.
So we've got a use case that we've spent a lot of time working on, and it's hitting pilot this summer. But it's moving the fact that it's a credentialing and licensing platform, but it's moving the fact that credentialing body or person with the authority to check something, have picked up the phone and called Vanderbilt Medical School and said, did Dr. Smith go to Vanderbilt? And they return an answer, yes. That is obvious. It's checked in a provider system every 2 years. It's re-enrolled every 3 years into a payer system. So over the course of a physician's career, those data points are checked and rechecked like hundreds of times. We've got some crazy stories about holdups in the system. I think it costs $7,500 per physician. Net revenue loss to a hospital system where a physician sits unlicensed. So what the system we've built does, it allows any credentialing office to go through the processes they go through. Like you've got your checklist, like I called Vanderbilt, you put your initials in that box, but you also create a digital certificate that says, on this date, I checked and verified that Dr. Smith went to Vanderbilt. And now that certificate sits out there on the blockchain, and what you can do that you couldn't do before is pass that through a system as a primary source verification, because the next person can look at that verification and say, I can prove who did it, and I know that since it was done, it has remained unchanged because those signatures are still the same. And so we're working to make this just rails that credentialing systems run off. And the longer that system's in place, every time it's referenced, it becomes a sort of residual revenue stream for the original verifier, but it also adds the reputation of that asset. It now says, like 25 different hospital systems have checked this asset that Dr. Smith went to Vanderbilt. And as multiple physicians who have completed the program at Vanderbilt are added to the system's comparing those certificates and saying, not only do I know who verified it, but I know that all of the certificates coming out of Vanderbilt look like all the other certificates. So you start to sort of strengthen the reputation of those individual assets. You can just think about this. I'll give the one quick story. We had a hospital system CEO who had stolen an orthopedic surgeon from a competing hospital on the golf course in a previous weekend. And they were very proud of this, and they got the physician set up. But the special procedure that they brought the physician into was the program that he'd gone through the only person that could verify that system, verify the completion of that program, was on maternity leave, and the only key to the file cabinet was on her keychain. So they sat for 6 weeks until the lady came back from maternity leave with the key to unlock the file cabinet to say, yes, in fact, this physician had completed this specialty. So I'm pretty sure that cost the hospital more than the $7,500 a day that the average.
Yeah, and I would just add one thing that Giles said that I think is really important is that because you can capture these assets on a blockchain and the blockchain is replicated, so it's highly resilient, and you can check that transaction many years later, that history of interactions with the data creates value around that data that we don't have today. When you go and you are buying data sets, which is something, big companies definitely do. You buy large amounts of data, you use it to sort of figure out whatever marketing things that you need to figure out, and then that data, it decays, it has a shelf life, and it's because there's no way to prove the transactional integrity, there's no way to prove the integrity of the data within that batch that you may have received, and the important thing is there's no way to prove that to other people. You may be able to prove that to yourselves internally, but you're not able to establish a common ground outside of your ecosystem where you could reuse that data or make that data useful again to someone else. So in the example of the credential, it's a really interesting idea that you could issue this asset once, and as long as it maintains integrity, that asset is still valid. In today's world, we have so many business processes that are built around the idea that you have to renew things because we can't maintain the integrity of our information. Blockchains are really going to issue a paradigm shift around that.
Now, Kristin, you provided this slide that has a lot of lines on it describing blockchain. Do you want to?
Well, we've danced around it, and Emily did a beautiful job describing what's happening on this slide and a couple of questions earlier. But, we live right now in a world that is centralized. So that is the Facebook model right there. This decentralized world that we live in now. We send all of our money, all of our data, all of our whatever it is that we need from whatever entity, and we receive whatever we send it for the purpose for which we send it, right? But when she was talking about the different ecosystems and how the different vendors may work together, now we're in a decentralized world. So you can see that certain dots, so to speak, on this chart, are collective in one area, but then they're sharing in certain ways. So that is one picture of what could happen in the future, and then kind of the utopian blockchain vision, or what exists as the Bitcoin network, is this distributed network where everybody has equal access to the same information.
Is that data integrity maintained? What if that physician loses his liability insurance mid-year?
So, sorry?
Is the insurance company on one of those dots?
So, repeat the question.
So his question is, how is the data integrity maintained? What if the physician loses their license or credential within the year which was issued? So that's a really, I think, important question, because all the blockchain does is maintain the integrity of its transaction. So if the physician were to lose their license, but that change in state to their license was never published to the blockchain, then the blockchain wouldn't know that the physician has lost their license. So from a software perspective, we have to program our software to push the changes to the blockchain. So whenever there's a change that's made within our application, we publish that change. Something changed, we publish that to the blockchain. And so first, that's how you ensure that things that are happening outside of the blockchain ecosystem, like things that are happening in real life, how do they get replicated onto the blockchain? You have to write that event to the blockchain. And you can do that in an automated way from a software perspective. But the other question is, how is the integrity maintained? And so I think that's the cool part about blockchain is Giles mentioned an append-only data structure, which means that every transaction that's added to the blockchain ledger is added to the end. And then there's a subsequent transaction that's linked to the transaction before it, and then another transaction linked to that one. So you cannot go back in time and change transaction. I think if you want to look at the next slide, Like,
That's on the cloud.
oh, I didn't send the blockchain storage one. My bad. So you can't go back in time and change transaction A if we're on transaction Z, because then you would have to replicate or mimic or recreate every single subsequent transaction to replicate that chain with the historical change made. And so when he's talking about the computational power required to do that being way more than anybody would be willing to invest, that's kind of how that balances out. So each transaction is cryptographically linked to the preceding one, and then that whole transactional ledger is replicated in full across every distribution point, every node, every dot on the network has a full copy of that ledger. So even if you did attempt to edit the entry within your system, and you wanted to lie to the rest of the system, you would have to get every node in Graph C to agree to accept your change, and that's impossible. And so the integrity of the blockchain is really maintained by the fact that transactions are added on the basis of math, not business relationships. But is this a mathematically sound transaction? Yes, it is. Then it's replicated everywhere else. So if you were to put something bad on the blockchain, like if a physician were fully licensed to do what they were doing, but they committed fraud and it was all published to the blockchain, the record of that fraud would exist. And if that physician were found out, we would be able to go back to the blockchain and find out exactly at what point in time that fraudulent transaction occurred. And so from an enforcement standpoint, it can help you kind of audit criminal activity. The Bitcoin blockchain captures a lot of criminal activity, and it is definitely used to bust criminals all the time. And now criminals don't love using Bitcoin anymore, but they switched to something else. Monero, I don't know.
Yeah. Zcash.
Zcash. So
let me add to that real quick. Like the fact that a physician doesn't go to medical school. If there are elements in your record that are once completed, they don't change. And the fact that my father-in-law is a physician at HCA, and he, I think the residency program that he went to merged with a different program and changed its name, and his residency advisor has been dead 20 years. Like his primary source verification on the fact that he completed a residency is a nightmare. But the fact that he completed that hasn't changed in the 40 years since it was done. The fact that you don't have liability insurance, that's a recurring thing. So it doesn't relieve a body of the responsibility for maintaining things that aren't static. But a portfolio of these assets, the fact that like on day one, when you check all like whatever it is, 20 requirements to get a license to practice medicine in the state of Tennessee, on the day that those 20 things are completed, you now have a medical license. That license on that day is valid. You can append to that license to say it is no longer valid if something changes, but elements within that can remain, the elements that originally made that up don't change.
Why would that insurance company not be one of the dots on the distributed network and report that change to the network?
They would be.
It would.
They would be.
And right, Giles? Right?
Absolutely.
Yeah.
Like the goal would be, like, it's the value that's created when it's not my data, not your data, it's the data that sits between us. Like there's got to be creation of an ecosystem that proves to the participants that my being in this network is of more value in aggregate than it would be just me having my own copy. Like the fact that a physician moves addresses or changed phone numbers or changed his plans is not a competitive advantage among health plans. Like that address is just something they need to know and something they're going to get fined if it's wrong in their records. So like provided directory management is a big blockchain. A lot of exploration is being done around that because the fact that Aetna knows the address of that physician and Blue Cross knows that it's changed, like it's not a competitive advantage to either one because you're not going to change plans based on that information being correct. You just both need to know. So maybe there is value now in those two plans sharing that information rather than just spending all the time and money independently maintaining and verifying their own systems.
as we all learn, we're trying to take a new concept that you have, and we're trying to adopt it to a model that we think or a situation that we think. So you said mathematically the only way to change things in a distributed network is to get more than 51% of all the nodes to agree with that information. But how does that work with new information? So let's just take, for example, diagnosis code. If I have a very, very subspecialized practice that only handles ophthalmology codes, and if it's in a distributed network and our practice puts out to the rest of the network, hey, this patient came in, was seen on this day, and my doctor, the only doctor that's looked at this patient and actually made that diagnosis, we want to put this out to the network saying, this is real, and now that patient has a diagnosis. How do we do that if nobody else on the network knows that information? Like, all of a sudden, it goes to all the other nodes, and they're like, oh, yeah, Dr. X gave this patient that diagnosis. So when they go back and ping it the next time, the majority of the network has no real-hand knowledge that says that patient really does have that diagnosis. It just says one person on the network said, or one node on the network said that. So how does new information get added when the majority of the nodes have no idea that it's good information?
So,
how does that work?
So, you know, if I may jump on that one. So there's a difference between what the nodes are agreeing to and like what you're talking about. The patient coming into the office, getting this diagnosis. The nodes on a blockchain network are actually not going to be agreeing on whether or not that took place. What the nodes agree to is whether or not the transaction that was created by that event, whether or not that transaction follows the rules of the blockchain protocol. So those rules will say the transaction needs to be created by a valid digital signature, meaning the software that the physician is using to publish this event, that software has to be valid in the eyes of the blockchain. So the digital signature has to work, and the message or whatever event it is that they're trying to publish, from a technical perspective, it has to follow the rules. So as long as it follows the rules, it can get published. So in a flip side, if the patient never came in and the doctor wants to say, hey, this took place, and as long as the transactions follow the rules, it can be added to the blockchain and the nodes will agree to it. So this is a network level consensus that takes place on whether or not the transactions are structured appropriately. There's another level of context that we will have to build around judging whether or not those the data that those transactions represent are accurate. And so that would be sort of an off-chain validation that takes place with groups like Change Healthcare or your EHR or whoever your software provider is, who says, you know, the context of this transaction is also accurate. And so in a blockchain ecosystem, the blockchain is publishing a proof of existence that an event took place or that a transaction took place, but there's another level of context that exists on top of it that says this was accurate, this was valid in a business setting. And so it's that way that the blockchain network can also protect, it can agree on what took place without revealing the identity of the patient or what happened, because otherwise you would be saying in the transaction that's being sent to all the nodes, this patient got this diagnosis from this doctor, and every node in the network would see that. We don't need to share all that data in order for those nodes to agree that that transaction is sound. And so, so there's this new, outside of network level consensus, there's kind of a new application and software arena that's emerging, and this is kind of the stuff that we're building, and I'm sure you guys are working on this to an extent too, where basically, outside of what the blockchain transaction says, what are the competitive data processing services that you can run on top? So we know that these transactions are valid according to the blockchain, but is the data accurate? So now we can go and do some off-chain analysis where we actually go into the underlying data store and we look at the data and we say, this patient, their identity is verified, or these diagnosis codes are verified, and you can publish some of that metadata back to the blockchain. So anyway, that's a very complicated way of explaining that the integrity system that the blockchain provides is not the same thing as an accuracy system. So we're still going to need data processing services that guarantee the accuracy of the information that's being reported.
every entry point is a discrete point. So the fact that it's a single position, like it's always a single position or a single lab or it doesn't matter how many people know that person. Like every transaction starts in one place and then is broadcast to every node on that network. So it becomes a part of the shared data set. But every transaction starts at a single point.
Yeah, I like to use Bitcoin actually as an example for this too, because as a holder of Bitcoin, you could send Bitcoin to anyone, and the Bitcoin blockchain is just going to confirm that your transaction is following the rules. But there's another layer of business world context that judges whether or not your transaction was legal. And so if you're sending Bitcoin to me peer-to-peer, I think that's legal in America at least. But if you were sending Bitcoin to me to buy some illegal service or activity or good, that there's a special context that exists outside the Bitcoin blockchain that would govern that transaction as illegal. So on the Bitcoin blockchain, everything's happening the way it's supposed to, but outside of that network, it's still kind of up to the communities that sort of self-regulate to kind of figure out how to address the legalities or what the culture of those transactions should be. And so that's the example that I like to use. So if you're a service provider that's allowing people to send Bitcoin through your software, then it's your responsibility to ensure that they're not using your software for illegal activities. And that's where the money service business, MTLs, and all that stuff come into play. So in healthcare, it would be the same thing. Just because anyone can use the healthcare blockchain to do whatever they want, if I'm a software developer, it is my responsibility to make sure that they can't use my software to, abuse patients' privacy.
We are just about out of time, but does anyone else have any further questions? All right, well, they'll stick around for a few minutes, so feel free to ask any questions while we're done. I want to thank our panelists for being here today. This is very informative.